Welcome to Maths with EJD. We're still considering coordinate geometry. In the last video, I talked about polygons in coordinates. Now we want to look at centroid and perimeter of polygons and coordinates. As I indicated in the last video, I said that a triangle is the simplest, is the smallest, the uh, smallest form, so to speak, of polygons, right? And in the video where I talked about the triangles in coordinates, I had looked at things like centroid and incenter, circumcenter, orthocenter, and all of that for a triangle. But on a broad base, I want to look at centroid and perimeter of polygons in coordinates. And that's this. So polygons in coordinate geometry are shapes formed by connecting series of points or what you can call vertices in the Cartesian plane. So two key measurements are perimeter. Perimeter is the total boundary length. Okay, it's in another language, it's more like the distance around an object. So if you have a triangle, if you move around it, that's the perimeter. Okay, and the centroid is the geometric center or balance point of the polygon. So if you want to balance a triangle, or just like you have a triangular park, like we saw in the video about triangles in coordinate system. So you want to get the something like the in center, where you can locate a fountain so that can be equally accessed from almost every corner of the park, of the triangular park, that is. So these have wide applications in computer graphics, geospatial mapping, and computational geometry, right? So perimeter of a polygon now. So for a polygon with n vertices, x1, y1, x2, y2, up to x and yn, and the last vertex connected back to the first, the perimeter, of course, like I demonstrated in the last video, for every polygon, the starting point is also the end point, right? And that is why we have this particular thing that xn plus 1, comma yn plus 1 is the same thing as x1, y1. So where it ends is where it started from. So the perimeter is given as summation from I equals 1 to n of all the distances xi plus 1 minus xi squared plus then xi plus 1 minus yi all squared. So it means if you have if you have a decagon, for instance, a decagon is a 10-sided polygon. So you start from 1. So you have x2 minus x1 squared plus y2 minus y1 squared. Then you go x3 minus x2 squared plus y3 minus y2 squared, all the way to when I is 10. So you have x11 minus, x11 minus x10 squared plus y11 minus y10 squared, something like that. Okay, so that way. Now, let's take an example straight up. Find the perimeter of a triangle with vertices A, 1, 1, B, 4, 1, C, 4, 5. So you need to find A, B, B, C, and CA and add them all together. So AB is square root of 4 minus 1 squared plus 1 minus 1 squared. So that'll be simply 3 squared, which is 3 because this is 0. Then for BC, you have 4 minus 4 squared, that's 0. Then 5 minus 1 squared, that's 4 squared, which is 4. Square root of 4 squared is 4, of course. For CA now, C and A, 4 minus 1, or 1 minus 4, that's minus 3 squared, which is 9, plus 1 minus 5, that's 1 minus 5 squared. So you have 9 plus 16, that's 25. Square root of 25 is 5. So the perimeter of this triangle will simply be 3 plus 4 plus 5, and that is 12. Okay, so we can get that done easily using this simple code to get the perimeter like this. Okay, so what we did here, I think we define this polygon perimeter, and it takes in the points, and then we get a perimeter of 12.0 like we got there. Then let's talk about the centroid of a polygon. The centroid is the center of mass, of the polygon, and it is the average location of all points in the polygon, assuming uniform density. So it is the balance point where the shape would stay level if made from a uniform sheet. So the formula for centroid is this: polygon with vertices. So if you have polygon for a polygon with vertices xi, yi, so you have A to be 1 over 2. That I think that should be area now. Yeah. A is 1 over 2 square roots of that area that we just talked about now, xiyi minus xi yi plus 1 minus xi plus 1 yi, like that. So you sum it all up and take half of that. And then they now have for the centroid now, cx, that's 1 over 6 times the area into this whole expression. Then for the y component, we have 1 over 6a into all of that for the y, right? Like that. So not forgetting that xn plus 1, comma yn plus 1 is the same thing as xi, yi. So example, find the, yeah, find the centroid of a quadrilateral with vertices 0, 0, 4, 0, 4, 3, 0, 3, like that. So to compute the area, we use that formula. I mean, a better way to do it is we make a table 0, 0, 4, 0, 4, 3, 0, 3. Do I want to do that? Should I do that? Okay, I mean, this is about, so first of all, you can compute the area, which you can refer to the previous video to see how that can be easily done for any number of sides at all. So you tabulate and then you cross multiply and sum things up and subtract. So you get the area and then you can compute CXYI going by all this formula. Okay, so here now you have 1 over 6 times 12, that's A now. Then 0 plus 4, as we saw that as xi plus xi plus 1. So this is 0 plus 4 like this. Then you now have xi yi plus 1 minus xi plus 1y. Okay, so this xi yi plus 1, that's 0 times 0 minus minus xi plus 1 yi minus, that will now be 0 times 0 again. So you just continue like that, and cx will be 2, cy will be 1.5. Okay, so that will be the midpoint of all of that, 2 comma 1.5. So we can go, I think this looks a bit close to what we did for it when we did the triangle. Except that we have an extra 0.4 comma 3 to make it into a quadrilateral, which is most likely a square in this case, I think. So 0, 0, 4, 0, 4, 3, 0, 3. 0, 0, 0, 0. That's A. You can call that A, 0, comma 0. Then we have 4, 0, right? 4, 0, 4, 3, 0, 3. Then 4, 3. That's B now. That's B. 4, comma 3. As you can see here. Then we have 4303, right? Oh, it's okay, 4043, 40 should be 40. Okay, then 43, that is C. So C is 43. So we have C here, 4 comma 3. Then lastly, we have 0, 3, that is D. D is 0 comma 3, as you can see. So that's definitely going to be a square. So D 0 comma 3, like this. Now, and then we got the centroid to be 2 comma 1.5. 2 comma 1.5. That's the centroid. CXCY. So let's call the centroid. Okay, it's usually G, right? So that's 2 comma 1.5, right? 2 comma 1.5, yeah, right at the center. So, and that is centroid G. That is 2 comma 1.5. So that makes a lot of sense, right? So we have a square and the centroid is this, like that. So because you can see it is 3, 3 on all sides. Or is it 3, 3? No. It's not a square. I think it's more of a rectangle. 0 to 3, that's 3 here, 3 here. Then here you have on the y, that's 3, 3. Oh, it's a square, sure. It's a square. Definitely a square. Yeah, square. It's a rectangle, sorry. So 3, 4. Yeah, it's a rectangle. Okay, so that's that. And then we can use this Python code to bring that to life. Well, I mean, for the most part, coordinate geometry, you can easily graph it and see what is there. Okay. So without any code, it's pretty easy to go through normally. So you can also visualize the rectangle itself like this here. Yeah. Okay. Yeah. This is exactly what we did on Desmos already. So this is the code to get that done. I mean, you should have access to Desmos. It's free to use. So we have applications now. So in computer graphics, finding object centers for scaling, rotation, and transformations. In geography, determining the geographic centers of irregular regions. So Centroid and all that can help us. Engineering design, balancing shapes and calculating centers of mass. Then you have robotics, path planning around polygonal obstacles. Then in machine vision, it's good for detecting, or what you can call computer vision, for detecting and labeling object centroids in image analysis, right? So and that leads us to the practice questions, so we can try our hands to see how well the concepts have been understood. So find the perimeter of a quadrilateral with vertices 1, 1, 4, 1, 5, 4, 1, 4. Okay. So we can just update this code. Um, we can just simply update the code here. Okay, well, I can even copy and paste. So I copy this, and hmm, okay, I can even bring it after this, right? To show that it's just extra. So in this case now, I want to find the perimeter of a quadrilateral vertices. So that's 1, 1, 4, 1, 5, 4, 1, 4. 1, 1, 1, 1, 4, 1, 5, 4. I perceive this is a square too. 5, 5, 4, 1, 4. Excuse me, 1, 4. 1, 1, 4, 1, 5, 4, 1, 4. Okay, can simply get there. Okay, this is the centroid now. This is the centroid. What about the area? Okay, it is about the centroid. We need the area in particular. Yeah, we had something about the area. Okay, so does this work? So coming ahead of that, I think this is just designed for the red triangle. But let's see. So let's just bring this one here and see what happens. So that's the centroid we've got right there. Okay, let's see if the area thing works in this case. Yeah, that works. I mean, the perimeter rather. Perimeter is 13.16, blah, blah, blah. That's perimeter like that. And then we can also we can plot it, right? We can do the plotting to show the centroid and all that. So just bring this down now. And I think we don't need to change anything. Everything is fine so because it just flows. Yes, so you see this now. So the centroid is 2.76, 2.57. It's just about changing the coordinates and everything is new here. Okay, so that's something right. So this now is like a, what do we call this? It's this is a rhombus. So this is not what a rhombus looks like. I think it's a parallelogram. I forgot what this can be called now. So uh, yeah, I think it's a parallelogram, yes, because two sides are parallel, and then this one does not necessarily have to be parallel, and then you can see the centroid right here, and we found the perimeter here, 13.16 units. Then you can compute the centroid of a rectangle, so you can use the codes above and all that. Then determine the centroid of a parallelogram with vertices there, so you can work around all of this. So here now 1, 2, 3, 4, 5. So this is pentagon. Now you want to find the perimeter of an irregular pentagon with these coordinates. So you want to try your hands on that using the code or whatever it is you want to use. So with this, I come to the end of this interesting video about centroid and perimeter of polygons in coordinates like that. So don't forget the 10 questions to try your hands on. So, all right, let me know how helpful this is for you. And if there's something else you like on the trials, feel very free to let me know. All right. So, mm, if you have subscribed already, I thank you very much. If you have not subscribed, of course, go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can click on join to become a member of this channel. At You have three possibilities. You can become a member at three different levels with special privileges. Ultimately, don't forget to comment, like, and share this video and other videos on this channel so that more people can have access to the great content I have going on. Until I come your way again, keep doing maths right. Bye.